Hello, in this video we are going to study about sorting. Sorting is nothing but arranging data in ascending or descending order. Suppose, look here, suppose if we are given unsorted numbers, that is 2, 4, okay. So these are the numbers you are given, okay. Now when you do a sorting on it, you will be either arranging it in an ascending order or you can arrange it in descending order. Okay, so this is what is called as sorting, arranging of the values, unsorted values into sorted values. You can either arrange it in ascending order or you can arrange it in descending order. So these are the different sorting algorithms we have. Basically, we have 6 sorting algorithms, that is bubble sort is also there, which you have already studied in C. So I'm not going to discuss about that, and it is not there in our syllabus as well. So the remaining sorting algorithms are selection sort, insertion sort, quick sort, merge sort and heap sort. Today we are going to study about the selection sort algorithm. Okay. So now look here. I could explain this with an example. Okay. Now you are having an unsorted array. Okay. This is an array where elements are in unsorted way. Okay. And your array is having indexes, right? So always the array indexes start from 0, 1, 2, 3 and 4. Okay, so this is the index of the array and these are the values. Now you need to arrange these values in a sorted way, okay, in an ascending sorted way, okay. Now what you have to do is you have to make an index element. So first of all, consider this as your index element, okay. Now when this is your index element, you have to compare the rest of the array in order to find the smallest element, okay. So look here, so this is your index element and you need to find the smallest element from the remaining array. So 7 is not smaller than 5. 4 is small but it is not the smallest. Here when you look, actually 1 is the smallest among these 4, right? So what you will be doing is, so you are going to swap this with this. That is, 1 will take the position of 5 and 5 will take the position of 1. Okay. So the remaining is written as such. Okay. So this is what is called as pass 1. Once this is done, you will go to the next pass. Okay. So in this next pass, your index element will be 7. Okay. So this is your index element because you are already done with the first and your index element is 7. Now you are comparing, okay. Now we are comparing 7 with the rest of the elements, and rest of the elements is 4, 5, 2. You have to find the smallest among them, okay, the smallest among them. And if you observe, the smallest among the rest of the array is 2, right? So you need to swap this with this so that your array will be looking like this. That is, 2 will take the position of 7 and 7 will take the position of 2. Okay. The rest is written as such. Okay. So this is called as pass 2. Now, next pass. Here, your index element is 4. Okay. Now you need to compare 4 with the remaining elements, that is 5 and 7. You need to find the smallest, but there is no smallest, which means 4 itself is the smallest. So in the pass 3, everything remains as such. Okay. Okay. So you have to write the remaining as such. Okay. Now look here. This is your index element, right? Now you need to compare the remaining element with the index element. And you observe that this index element is smallest than the remaining array. So what happens is your array will be looking the same. That is 1, 2, 4, 5 and finally 7. Okay. So because when the value is not smaller than the index element, you don't want to swap it. You have to just keep it as such. So this is what is called as pass4. Okay. So with this, your array is sorted. Okay. So this is how selection sorting is done. First of all, you have to take an index element and you need to compare with the remaining elements in order to find the smallest. And if you find the smallest, you have to swap the position of the index element with that smallest element. Okay. And this process has to be continued until you reach the end of the array. Okay. So this is what is called as selection sorting. And if you observe something, how many passes are there? Look here, there is 5 elements, right? Suppose that is if there is 5 elements, here there is 5 elements, so how many passes? 4 passes, right? So we can make a conclusion that if there is n elements, then how many passes will be there? There will be n minus 1 passes. Okay, so this is the rule. So if there is n elements, there will be n minus 1 passes. Okay, so this is the logic behind the selection sorting. Now let us discuss the programmatic side of this. So this is how the selection sort is made into a program. So if you observe that there is actually two for loops, right? One for loop is for denoting the number of passes. Okay, how many passes are there? There is n minus 1 passes. If your pass is starting from 0, it has to go until a value less than n minus 1. Okay, so here we started 1 and we have gone until n minus 1. But in this loop we are starting from 0, so we have to go to a value less than n minus 1. Okay, so this is the number of passes, and initially, and the next is the number of comparison in a pass. Look here, this is your first pass, right? When you are in the first pass, you are comparing the index element with the remaining elements, right? So if this is the index element, what are the remaining elements? You can see when you are at this element, you are comparing these elements with this much of elements, right? So if this is I, what is this? This is I plus 1. I plus 1 to n minus 1 is where you are going, right? Yes, you're going until n minus 1. So that is what is written here. So j is nothing but I plus 1. You can call this position as I plus 1 and you can assign it to j. So you can call this as j. So j need to travel until where? You need to go until n minus 1. So that is what is given there. Less than n means n minus 1. Okay. So the first loop will be representing the number of passes and the second loop will be representing the number of comparison in a pass. Okay. And here in a pass, actually what you are doing, actually you are finding the smallest number from the remaining array, right? So how do you find the smallest number? First of all, you imagine that or you assume that I is the smallest number. Okay, that is I. The location I will be containing the smallest number. Okay, that is the position 0 will be holding the smallest number initially. Okay, that is what we are assumed about, because in each pass we are trying to find the smallest element, right? So initially we don't know which is the smallest number. So what we have to do is we have to imagine that let the index element be the smallest element. Okay, so that is just an imagination, because we will know about it only after we passes through the remaining elements, right? So inside this, so that means when we are on the first pass, what you are doing is we are comparing each of the remaining elements with the minimum element. Okay, that is what was the minimum element here, it is assumed Here we are thinking that minimum is is minimum is giving the position of the element, that is the zeroth position. So A of min, suppose your array is called as A, then A of min is what? A of 0. What does that mean? That is 5 is the minimum amount. Minimum value is our assumption, right? So minimum means the position and A of minimum will give the value. Okay. So we need to compare the values, that the remaining values, with A of min. Okay. So this location is J, right? This is, we are going from J to n minus 1 location, right? So first of all, you have to compare A of J. What is A of J? J is 1. A of J is 7. You are comparing 5 with, that is A of J. A of J is what? A of J is A of 1 is less than A of 0 is what we are comparing. A of 1 is 7 and 7 is 5. A of 0 is 5. So we are comparing these two, right? If ever we find a smallest element, then what you have to do, you have to make an assumption that that will be the next smallest element. Okay. So I could explain this better. Look here. Let me delete this and I can explain this. So I hope you understand the positioning, right? Min is actually containing the index, not the value. And A of min is containing the value. Okay, so do not confuse with that. So now let me give a more deeper explanation on this so that you will get a better understanding. So look here, I'm just deleting things so that you get. Okay, so initially it was 5. Okay, so this is it, right? So when you are starting, this is your index element, right? I is your index element. Okay, and you are assuming that minimum is containing the location of I. That is, you are assuming that your index element is the smallest element, because why? You don't know which is the smallest element, so you're just giving an assumption. Okay, you will change the assumption by traveling through the array, right? When you are traveling through the array, you will start knowing which is the smallest element, then you will actually correct your assumption. So that is what is the principle behind. So initially you don't know, so you're just making an assumption and you're working with that. So initially you think that A of min is the smallest element. What is A of min? It is nothing but A of 0. What is A of 0? It is 5. You are assuming that 5 is the smallest element, right? And what is this location called? This is I plus 1. I plus 1 is nothing but J. It is given here. So you are comparing index element from J to n minus 1 location, right? So what you are going to do is you are comparing J. That is, this location is J. So J is containing, if J is containing the location, A of J will be containing A of 1. A of 1 is what? A of 1 is 7. Okay. So if you want to compare the values, give A of J. Okay. Like that. So you're comparing A of J with A of min. Look here, A of min is 5, right? Your A of min is 5. A of min is 5, right? You're comparing A of J with A of min. This is no longer smaller, right? They are not smaller. A of J is bigger than A of I. So you don't have to change your assumption. You will not go inside this loop. Then what happens is you go to the next iteration. You have done with this thing. You have done comparing with this particular number. You're comparing the index with this particular number, so it is no longer smaller, so you just go to the next one. So you're comparing this with this, right? You're comparing 5 with 4. That is what is happening. Now your J is here. You're comparing A of J with A of min. Okay, your min is this. Okay. Now what you're going to do is, you see that actually J is smaller than 5, right? If it is smaller than 5, your assumption is wrong. Then you have to correct your assumption. So what you do is, you do J is equal to min. What? Initially you thought 0th location value is the minimum one. But now you understand the second location is value is much smaller than the 0th location value. So what you do is you correct it. Right? Right, you correct it. Now on the next iteration, your J is here. Now we are comparing J. What is J? A of 3 with A of min. What is A of min? A of 2. What is 2? That is 4, right? You're comparing A of 3 with A of 4. Now you understand that uh, A of 3 is smaller than A of 4, right? Again, your assumption has to be corrected. So you make what? You thought the second location element is the smallest. Now you understand there is more smaller elements than that, and you correct the location with 1. You say that minimum is residing, your minimum is residing in position 3. That is the correction that you make. Okay. Now what you do is, you are again going, your j is here. Okay, your j is here. Now when your j is here, you are going to compare a of j with a of min. What is a of j? A of j is nothing but a of 4. A of 4 is compared with a of min, that is 3. That is, your 4 and the 3 is compared. The values is compared. Okay. Okay. So this is your minimum right now and your j right now. So when you want to compare the values, what you have to do? A of j is 2 and A of min is 1. Okay, I hope the concept is clear. If it is like that, then you have to change the minimum value. So when you reach here, you have already reached the end of the first pass, right? So by the time you know which is the smallest element from the remaining array, and that is stored inside where? A of min. So the smallest element is what? That is 1. That is, it is inside A of 3. That is, min is 3, so A of 3 will be containing 1. So you were comparing this is the index element, you were comparing with the remaining elements, right? So now from the remaining elements, you have found out the smallest one. Now what do you have to do it? You have to just swap the position. That is what we have told, right? So that is min if it is not equal to I. What is the meaning of that? If the location of the minimum is not equal to the index value's location, okay, then you have to swap it, which means that this minimum is smaller than the index value is the meaning of it. Then you need to swap it. This is the code for swapping. I hope you know the code for swapping. So this is what is done. And the steps are repeated for how many times? For n minus 1 times. That is the number of times the passes are, right? So this is the logic behind selection sorting. I hope the point is clear, right? Yeah, so this is the logic behind it. Okay, now let me give you the full explanation of the program. So this is like it. This is the code, full code. Okay, now look here. The highlighted code was what I was explaining. If you want to do the highlighted code, actually you need to get an array, right? If there is an unsorted array only, you can make it sorted, right? So as you all know, if you want to sort something, you need to have an input, right? So this is how you have to give an input. I hope you are very much familiar with this, because this is the code for inserting value into an array. Look here, you have made a bigger array here, and out of which you are asking the user for the limit. Okay, because the size is 50, right? You don't have to use the entire 50 size, so you can ask the user for his requirement. Once you give the requirement, you can input only that amount of data into it. Suppose if he is giving 5, then out of 50, only 5 spaces of the array is used, and you are inserting 5 elements into it. Once you insert, then the code for selection sorting is to be written. And after selection sorting, you have to see the sorted array, right? And if you want to see the sorted, you have to display it, and this is the code for displaying. So these two codes are very much familiar to you. That is, giving an input to an array and displaying is very much familiar, because we have already discussed about these things before. So this is the entire programs looks like. Okay, fine. So this is called selection sorting, and this is the implementation part of selection sorting. And I need to tell you one more thing, that is about the complexity of the algorithm. That is, clear. Okay, the complexity of the algorithm. Okay, now I think I should, okay. I will write here, that is the complexity. Complexity of selection sort is what we are going to see now. Okay, so let us take the same example as we have discussed before. 5, okay, 5, 7, 4, 1, 2. So this was this unsorted array which you had, and these are the index values of index values of your array. Okay. So you want to make it sorted. What you do is you make an index element and you compare the index element with the remaining element. So from the remaining elements, if there is a smallest element, then you swap it. Okay. So 1 will take the position of 5 and 5 will take the position of 1. Then the remaining is written as such, right? 7, 4, 2, right? Then in the next pass, this is pass 1. You have already done with 1, so you go to the next element. That here this is your index element, so you're comparing with the remaining element. So you need to find the smallest one, and this is the smallest one, so you need to swap it. So what happens? So 1, oh, sorry, let me change the ink so that you get a better understanding. That is why. So 2 will take the position of 7 and 7 will take the position of 2, and the remaining elements are written as such. Okay. Now you are already done with 2. Now the index element is this. So you make a comparison, but there is no smaller element, so it is remained as such. There is no swapping required, right? Because there is no smallest element in the remaining array. All the rest is written as such. And next your index element is this. Since it is the smallest than the remaining, everything is written as, nothing is changed, right? Nothing has to be changed because there is no swapping required, right? So this is it. This is how your sorting looks like, right? So this is it. So if you observe something, when your index element is this, okay, when your index element is the first element of the array, and if you are, how many comparisons are you making actually? Look here, this is an array of size 5. And when your index element is at the first position, you are making actually 4 comparison, right? You're comparing this, 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 and this. So you can say 4 comparison in first pass. And in the second pass, okay, you're making how many comparison? You're making 3 comparisons, right? And in the third pass, how many comparison? 2. And in the fourth pass, you're making 1 comparison, right? So as the passes reduces, the number of comparison is actually reduced, right? So we can generalize this thing. That is, in the first case, when there is 5 elements, you did 4 comparison. So you can say that if there are n elements, in the first pass, how many comparison you are making? N minus 1 comparison, right? Here 5, then you did 4 for the first pass. So if it was n, then it is nothing but n minus 1, right? So n minus 1 plus n minus 2 plus etc. plus 2 plus 1 is the comparison that you make. So this is the general concept, right? So if you expand this, then you can write as n into n minus 1 by 2. Okay. So this can be written like this, and once you solve it, you get n square minus n by 2, right? So you take the higher degree polynomial and your complexity is big of n square. So this is the complexity of your selection sort. I hope you understand this thing. Now I want you to do a small assignment on this, because you will have a better understanding if you do assignment. That is why. So I want you to solve this. That is, suppose if you are given 7 elements, okay, your array is having 7 elements, 1, 2, 3, 4, 5 and 6. Okay, let this be an unsorted one. Okay, I want you to do selection sorted on this. You have to write each step of this and submit it today, so that you will get a better understanding. That is why. So this is the array which you need to sort it using selection sorting. You need to write all the steps and solve it. So thank you.